Your social studies teacher decided to give you an assignment that you had to write a paragraph about your descendants. So you have to write a paragraph about and your mother, your father, and in this case, they're like just biological descendants, so we don't have to do extras if you have them. Just your biological mother, biological father, and then biological grandparents of them. And they say, yeah, how many generations do you have to go back? They say you have to go back 4 generations. Whew, how many will that be? Well, if you went back 1 generation, you'd have your 2 parents, right? So you'd have to write 2 paragraphs there. And then you have your grandparents. Now that would be, oops, that's not 4. 4 of them. And then if you went back there, the 3rd generation, you'd have to write another 8 paragraphs. And then if you went back another generation, there'd be another 16 paragraphs. That's a lot of paragraphs all of a sudden. Like go back 4 generations, that's a big assignment. And we have to add things up. So you know how we added up arithmetic sequences? Now we're going to start adding up geometric sequences. This one, probably just do 16 plus 4 is 20, plus 10, 30. You'd have 30 paragraphs to write. What we're going to do is we're going to see how would we add these things up quicker. Okay? How do we get a formula for adding geometric ones? So what I'm going to do is I'm going to pick 3, but I'm going to go by doubling. So I have a term 1. And the next one would be doubling 24. And let's say you kept on going for a while. So 48, 96. Let's go up to there. 1, 2, 3, 4, 5, 6 terms. The last time with adding, we flipped them around backwards and they all added up to the same thing. Can you see that this time they don't add up to the same thing? And this is equal, I'm going to call it S. In fact, it's 1, 2, 3, 4, 5. It's technically S6 of this sequence. You're adding up the first 6 terms. The strategy that, and the idea that came up with figuring out sums of geometric ones, with arithmetic ones we came up with a strategy for adding. With geometric ones, we come up with a strategy that's subtracting. So what they did is they look at what you're multiplying by. Can you see that your R value in this one is 2? So if I took my original sum and multiplied it by 2 again, I'm going to do that above and in green. If I multiplied everything in here by 2, what would happen to 3? It would become 6. What would happen to the 6? It would become 12. The 12 would become 24. The 24 would be 48. The 48 would be 96. And the 96 would turn out to 192. And this will give me a shortcut for adding these up quickly. Can you see that if I take 2 sums and minus 1 sum, I would be left with just 1 sum? 2 sums minus 1 sum is 1 sum. If I subtract on the other side, do you see that subtracting would make all of those go away? If I do the top one, the green one, minus the black one, they would all go away and I would be left with just the 192 minus 3 for 189. And if you add 3 plus 6 plus 12 plus 24 plus 48 plus 96, you will get 189. It becomes a shortcut for adding. What if the R value was something different? What if the R value wasn't 2? Let's look at another sum of 5 terms. I'm going to start with 1 and I'm going to multiply, no, I'll start with 2. I'll start with 2 and multiply by 3. So it'll be 2, 6, 18, 54, 162. Hoping that the mental math worked there. Okay. And now to get all of these numbers to match up, I would have to take my sums, and since my R value this time is 3, I would have to multiply my sums by 3. What would that do? Well, the 2 would become 6, the 6 would become 18, the 18 would become 54, the 54 would become 162, and the 162 would become, oh my goodness, 486. Yes, okay. And now if I subtract, well, this time 3 sums minus 1 sum, I would still be left with 2 sums. And on this side I had 486 minus 2. How would I find out what the actual sum is? I'd have to divide it by 2. So it'll be 484 divided by 2, which is 242. And if you add those up, you get 242. This strategy will help us develop the formula for adding geometric sequences, which is called a geometric series. What did we do to find the sum of any geometric sequence? What did we do? We took whatever the last one was, right? Like if we circle important things in the formula, maybe I'll just, instead of, I'm going to circle things, wow, I knew it was going to be big. Here we go. We'll look at this right here and circle the important things. I had the 486. The 486, how did I get the 486? I took the last term and multiplied it by my R value. So I'm going to take R times my last term. I then subtracted the 2. The 2 was my first term. And I had to divide. When R was 2, I didn't have to divide. But when R was 3, I had to divide by 2. If R was 5, you'd do a 5 up here. You'd have to divide by 4, so it's going to be over R minus 1. This is the idea we just did. What we just did with that idea is we took the idea and created a formula. Now on your formula sheet, the formula sheet has this formula written out as follows. And I'm going to show you, the formula sheet writes it out like this. Term 1, so the formula sheet has it written out like this. We developed the formula this way. So I'm going to talk a little bit about how they changed it, because I like it when you can develop a formula, and if you wanted to use this formula, fine. Notice on the formula sheet, it doesn't use Tn. So the first thing on the formula sheet, when they give us this formula that they did, and then it's just good practice to rewrite everything except for the Tn, because I notice on the formula sheet, they don't use the Tn. Well, in a geometric sequence, we have a formula that Tn is T1 times r to the n minus 1. So I'm going to rewrite where the Tn was as a T1 r to the n minus 1. You can just watch. You don't have to write this down. But it's just how do formulas get manipulated? The nice thing about changing the Tn out for the formula is now you have just T1s and r's instead of this one has r, T1, and Tn, 3 things you have to plug in. Now that I replace it, I have 1 thing I need to plug in. And exponent rules would say that if I do an r times an r to the n minus 1, this is an r to the 1. When you multiply with the same bases, you add the exponents. So if I do 1 plus n minus 1, this becomes term 1 times r to the n minus term 1 over r minus 1. Still haven't got it to look like the equation that they have right there. They do a little bit of fun with negatives. If I factor out a negative 1 out of the bottom, it will change to 1 minus r. Because if I pull out a negative, the r would become negative, and the 1 would become positive. If on the top I pull out a negative term 1, if I factor out, because there's a common factor of term 1, we can factor out a term 1. But if I factor out the negative term 1, then this negative term 1 will become positive 1. I'll write that first. And if I take out a negative term 1 out of term 1 Rn, I get a negative r to the n. And of course, a negative divided by a negative, those could cancel out. And we have this version of the formula that's on your formula sheet. Okay? The problem with the version on the formula sheet is you don't get it naturally by thinking about the sequence. I wanted to show you where the sequence, the formula comes from naturally. And then one of the things you do in higher level math is you have to rearrange formulas all the time. Physics is all about that. Here's a formula. Move things around. Here's a mathematical formula. How do we move things around to get it to match what's on your formula sheet? And this is on the bottom. That formula is on your formula sheet, also on the bottom of page 44. And we can highlight this new definition. That a geometric series is just the sum of the terms in a geometric sequence. So sum 1 would be this, the first one. Sum 2 would add the first 2. Sum 3 would be adding the first 3. And of course, we have the formula at the bottom of the page. Oh, I guess if you put what we multiplied underneath, you get the 1 minus r rather than the r minus 1. You have negative values. But that formula is on our formula sheet. So with that, we can go to example 1. And the first thing you're going to need to do on tests is make sure you know which formulas go with which things. So if this is a geometric series, you take out your formula sheet and say, I know that I have to use this formula. And now I need to plug everything in. I want to find S12, the sum of the first 12 terms. So I say, I know that n is going to be 12. Do I know term 1? Yes. Term 1 is a 3. Bracket. 1 minus. Do I know what I'm multiplying by each time? Can you see that from 3 to 12, you're multiplied by 4, multiplied by 4. So my r value is 4. My n was 12, so it'll be 1 minus 4 to the 12, divided by 1 minus 4. And from here, this is just a calculator question. If you have a graphing calculator, and some of the calculators will do this as well, but what's really nice is you could type this whole thing in exactly as you see it. On the graphing calculator, if you have one of the newer ones, and if you go to the F1 menu up here in green on mine, so I have to hit my alpha button and then Y equals to go to F1. The very first one is a fraction button. I love this fraction button because I can type fractions in my work exactly as I see them. So what did I have? I had 3 bracket 1 minus 4 to the exponent of 12, close that bracket, over 1 minus 4, and I can type, I don't even have to do the 1 minus 4 in my head, which is negative 3. I can type that in. I can figure out things slowly if I want to, but I can type it in all at once. 16777 So the sum of the first 12 terms will be 16,777,215. A very, very big number. And since geometric sequences get big quickly, does it make sense that if you add them up, it'll also get big quickly? All right, so let's try some of these right now. 4, 5, 6, and 7.